Hello again. This is the third film in the series about moles and mole calculations, which you might be watching in Year 11. Um, this one is about a very important quantity in mole calculations called the molar mass, and leads on to how you find the percentage of an element by mass in a substance. Okay, finding these things is quite simple arithmetic. It's not something to be scared of, but you do need to remember some rules. So get those rules remembered. Practice this so that you can't forget them, and this should be quite a simple thing to do. Okay, hopefully by the end of this film you'll be able to look up relative atomic masses in the periodic table and find the molar mass of elements and compounds. Molar mass being the amount of mass that one mole weighs, okay? And then you'll be able to use the molar mass of a substance to find the percentage by mass of elements in that substance. Okay, so let's see how we do these things. First of all, let's have a look at what we mean by relative atomic mass. I'm just going to choose some element from the periodic table using my WACE data sheet, okay, which we get given in every test. Okay, I'm going for beryllium. No other reason than my eyes just fell on beryllium there. So 9.012 is the relative atomic mass of beryllium. What this means is that the relative atomic mass of beryllium is 9.012. But you might ask, well, what are the units and what's it relative to? Okay, well, everything on the relative scale is relative to 1/12 of the mass of carbon-12. Okay, so if I took the mass of a carbon-12 atom and divided it by 12, that gives me 1 on my scale. Okay, so what that means is that the mass of beryllium is 9.012 times as great as 1/12 of a carbon-12 atom. Okay? If you give it as a relative quantity, it doesn't have any units. It's just saying it's 9.012 times as big as something. Okay, so it doesn't have a unit. But you could think of it as saying, well, this is 9.012 grams for every mole of the substance. So if I have a mole of beryllium, I'm going to have 9.012 grams. So the units, we can either have no units, or if you're talking about how many grams per mole, right, then you include the unit grams per mole. Okay? So let's find the molar mass for a couple of things. Okay? Elements and compounds. Well, elements come in kind of different kinds. We've got elements like sodium and aluminium and sulfur, okay, which are written just as single atoms. Okay, so 1 mole of sodium weighs however much the relative atomic mass of sodium is. Same thing for aluminium, same thing for sulfur. But some elements like oxygen, like hydrogen, like nitrogen, like all the halogens, that's all group 7, like chlorine, okay, they have 2 atoms in every molecule. So if I have a mole of oxygen, because oxygen occurs as O2, the molar mass of oxygen is twice the relative atomic mass of oxygen. So oxygen has a relative atomic mass of 16. The molar mass of oxygen naturally occurring, O2, is 16 times 2, which is 32. Hydrogen, naturally occurring, H2 molecules. 1.008 is the relative atomic mass of hydrogen, so that's the mass of 1 mole of atoms of hydrogen, but 1 mole of hydrogen has 1 mole of hydrogen molecules, so twice that number of atoms. Okay? So if these are left as relative quantities, the relative molar mass of oxygen, or the relative molecular mass of oxygen, is 32. Relative mass of hydrogen molecules is 2.016. For sodium, it would just be 22.99. Okay? Or you could say that 22.99 grams per mole is the molar mass of sodium, 1 mole of sodium, or 32 grams per mole for oxygen. Okay? These elements here should give us a clue about what we do with compounds. So let's say, I don't know, let's say I've got magnesium chloride, okay, and I want to find its molar mass. Well, magnesium chloride, 1 mole of it has 1 mole of magnesium and 2 moles of chlorine atoms. So if I add the relative atomic masses of those things, so 24.31 plus 2 times 35.45. I'm remembering some of these numbers but not others, but you can always look them up on the periodic table. Okay, then that sum is going to give us the molar mass of magnesium chloride. Okay, it's going to tell us how many grams each mole weighs. That's what a molar mass is, and you might hear it called other things like formula mass or relative molecular mass, okay? But they all mean the same thing, the mass of 1 mole of a substance. Okay, here's another couple of examples, one of them which I've done already, okay? But just to highlight what we're doing here, O2 is oxygen, okay? You've got to remember that for some elements they're going to be diatomic molecules. O2 is 16, because one oxygen atom has a relative atomic mass of 16 times 2, that equals 32. Magnesium nitrate, here's where you have to be able to figure out the formula of a substance, because otherwise you can't figure out its molar mass. Okay, magnesium is a 2+ ion, the nitrate ion is a 1- ion, so we've got 2 nitrate ions to every magnesium. So this will be 24, what did we just say it was? 31, plus 2 nitrogens, so 2 times 14.01, and 6 oxygens, 6 times 16. Add them all up, and you've got the molar mass of magnesium nitrate. Just included this example here because there's some compounds in chemistry that are hydrated. That means they've got water of crystallization in them and they have funny looking formulas. Okay, what does this mean here? This 5 multiplies everything after it. Okay, so in other words here I'd have to add the mass of copper, which is 63.55, plus 1 sulfur, 32.06, 4 oxygens here, but another 5 there, so 9 times 16, and 10 hydrogens, 10 times 1.008. So that is how I'm finding the molar mass of substances. Knowing the molar mass of a substance is really important if you want to calculate how many moles you've got if you're told its mass. And that's what the next film talks about. It talks about interconverting mass and moles. But it's really important that you know how to calculate a molar mass, otherwise you won't be able to do those problems. So make sure you understand what's in this film, have a bit of a practice, and then see if you can move on to some more complicated calculations. Yes, of course. We've got to do percentage by mass. Okay, forgot about that. So let's find the percentage by mass in ammonia. With these kind of problems, you've got to find the molar mass first, and you need to know the formulas of things, or figure them out. So ammonia is one of those ones you just have to remember. It's NH3. The percentage nitrogen in ammonia is just how much the nitrogen weighs in here. So this is, the nitrogen weighs 14.01. Okay, the hydrogens weigh 3 times 1.008. Okay, but the nitrogen as a fraction of that is just 14.01 out of all that lot. Multiply that by 100% and I've got the nitrogen percentage, which off the top of my head it's about 14, well it's 14/17 roughly. So whatever that is, it'll be probably 80 odd percent. Aluminium oxide, be able to figure out its formula. Okay, aluminium is a 3+ ion, oxide is a 2- ion, so Al2O3. Figure out the formula mass of that, or the relative molecular mass, or the molar mass, so that would be 2 times 26.98 according to our periodic table, plus 3 times 16, which is 54 and 48, so about 102. Okay, and out of that, 54 approximately, or to be precise, 2 times 26.98, so about 54 of 102 is aluminium, right? I don't know why I'm doing that, because we're being asked about oxygen. So the oxygen would just be 3 times 16, which would be 48 out of 102, okay, times 100%. So that is how we find the percentage of an element in a compound by mass. You need to be able to find its molar mass first, okay? But remember, one of the most important things about this film is finding molar mass, because we can use it in the calculations that are coming up in the next film, which is about interconverting mass and moles.